Okay, so we are in section 9.6. We're going to graph the other trig functions that we haven't graphed yet. So that is secant, cosecant, and tangent and cotangent. We're going to focus first on the graphs of secant and cosecant. We highly rely on the reciprocal properties when we're graphing secant and cosecant. It makes them much easier. So remember, cosecant of x is the reciprocal of sine of x, and secant of x is the reciprocal of cosine of x. So what happens when we graph these is we get some important features that we are going to take advantage of. And one of them is the fact that sometimes our denominator will equal 0. So for the case of cosecant, whenever sine of x equals 0, this means by definition that cosecant of x is the reciprocal of 0, or 1 divided by 0. This is an undefined number. We do not know. We may not divide by 0. That does not exist. Same thing for secant whenever cosine equals 0. So graphically, what happens when you have a number divided by 0, or your numerator is non-zero and your denominator is 0, I don't know if you remember this or not, but from the rational functions, whenever your denominator equaled 0 but your numerator did not, we had vertical asymptotes there. Vertical asymptotes. And so we're going to start with graphing those. Well, we're going to graph those. I don't know that we exactly start with that. Okay, and then the next thing that we're going to do after we put in our asymptotes is we're going to take advantage of the nice points. So whenever sine is 1, then cosecant is 1 over 1, which is 1. Same thing for secant when cosine is 1. So whenever at these spots, we're going to have some sort of x value, but the y coordinate is 1, and this is our only really nice point. Well, we have those really nice points. And then after that, we're going to put in those weird parabola things. I know you all have graphed these before, so you know what I'm referring to. All right, let's start with y equals cosecant of x. The way you start is you actually start by graphing sine. So I'm going to start by graphing sine of x, and we're going to do this just the way we graphed sine in the last section. So we put in our pi's and 2 pi's, and then 1 and -1, our amplitude. Sine is 0 on the multiples of pi, so I put those zeros in. And then it alternates between 1 and -1. And I'm dotting this graph because I'm going to use the graph of sine, but it's not a part of the graph of cosecant. Okay, the next thing I'm going to do is what I talked about up here with the vertical asymptotes. Every time that sine is 0, 2 pi, 0, -pi, -2 pi, when I reciprocate those zeros, I get vertical asymptotes. So I'm going to put in my vertical asymptotes. And then the next thing I mentioned is that at these nice values of 1, my cosecant value is actually going to be 1 as well. That also happens with -1. Whenever sine of x is -1 down here at 3 pi halves, then the cosecant of x is also -1 because it's 1 divided by -1. That's still -1. This also happens at -pi halves. And so you actually have these blue points, and then when you reciprocate the other points in the sine curve, they produce these weird parabola things. So they look like parabolas, but they're not because they have vertical asymptotes. And so this blue picture is your cosecant graph. And now over here, we're going to graph secant. I'm going to start the same way, except instead of graphing sine, what should I graph? I should graph cosine because that's the reciprocal one. And I'm going to use my amplitude of 1. Now, cosine is 0 at the odd multiples of pi halves, at these half marks. And so I'm going to put in my zeros there, and then cosine alternates between 1 and -1. Okay. So now there's my cosine graph. Let's graph secant in green. At the zeros, every time cosine was 0, I need to put in a vertical asymptote because I don't get a value when I flip over 0. I get 1 over 0. That's a vertical asymptote. But when cosine was 1, 1 over 1 is still 1. So these are nice points. And then same thing for -1. And now I can put in my weird parabola things. They alternate, just like in cosecant. These are copies of each other, but then shifted. They're strange. Okay, so those are my secant and cosecant graphs. Now we're going to shift these graphs around. Okay, so I'm going to have you do the same things we did with sine and cosine. You know, what happens if the period changes and the amplitude, and then there are some shifts. All right, we're going to start with this graph. It's really not too difficult. It's essentially the same thing as what we previously did. We're going to do all of these shifts, but on the reciprocal curve on either sine or cosine, and then we put in our vertical asymptotes and our weird parabola thingies, and then that's it. Okay, so here I have secant. So I'm going to graph cosine. Put in my half marks. Now my amplitude this time is 2. That's kind of too skinny. I'm going to go 2 up and 2 down. And I know my graph is going to eventually shift down 3, so I'm going to add this. Okay, and then cosine was 0 on the halves. So I'm going to put those in. And right now I'm really just focusing on this cosine graph. Really just focusing on the cosine graph. It should be f of -2. Okay, and I'm going to dot it, but I'm going to put this in here. I did this very poorly over here. And I have already adjusted for the amplitude when I did this. Now let's adjust for the period. The period is going to be 2 pi divided by pi, because pi was the b here. So when I take 2 pi divided by pi, I just get 1, 2, -1, and -2. Okay, now I also have a horizontal shift and a vertical shift. By the way, I'm going to change this. I'm changing the problem. I want this to be a minus pi halves. I want it to be a minus pi halves. That'll just make the shift much nicer shift so that we can actually count it out on the tick marks. And I will always do that for you. Have a nice shift, as long as I'm thinking clearly when I make up the problem. All right, so we're going to have a horizontal shift, and it's going to go right, because of the minus, pi halves over pi, because we always have to divide by that b. So it's going to go right 1/2. And then finally, in the end, you have that -3, so it's going to go down 3. So I'm going to go right 1/2, down 3. All right, so let's do that. Let's take this point here, the 0, 1, well, 0, 2 point. I'm going to go right 1/2. So each tick mark, notice, is 1/2, and then down 3. Right 1/2, down 3. Okay, before I do that, let's move my horizontal axis down 3. If you kind of put in this middle line, it's a midline, the midline of your cosine, your old x-axis. Move your old x-axis down 3. That will really help you to figure out where your points are going to shift to. So all of these high points here are going to still be above that line, but they're going to be right 1/2 and down, so that they're still just 2 above it, though. And that one would be over here, and this one will be here. Okay, and then let's take our midpoints, or our points that are zeros. We're going to take those right 1/2 and down 1. So now this is on the 2. So all of my zeros are now on those original multiples of pi. Okay, then our low points are going to be, I think I have too many here. It's going to be a low. This is not, yeah, and then this is going to be a low. And then I'm going to graph this. So I shifted right 1/2 and down 3. You can see that. It may be making it dotted, not dotted would have been easier. Okay, and now I'm going to change this graph. So this is, all I have done is graph this thing, but with cosine. And so now I'm going to switch it to a secant. So notice where your zeros were. This is another reason why it's good to draw in that horizontal line, because it's easier to see where your zeros are. Let me change that. I want that to be dotted. This is a vertical asymptote. And then I put in my weird parabola thingies. And this green graph is the final version. And this was a pretty tricky one. This is about as hard as it gets because we had every single kind of shift, plus we had the reciprocal graph. Okay, so here's one more. This one has cosecant in it. Okay, so I'm going to start by graphing sine because this one is asking for us to graph cosecant. So we start with sine. And the amplitude is still just 1 here, so 1 and -1. Sine is 0 on, not that one, on the multiples of pi. So I'm going to put those zeros in. And then notice what happens is this has a reflection. And so normally sine goes up after 0, but now I'm going to make my sine go down. So I'm taking care of the reflection here. Okay, I'm going to go ahead and dot this. Okay, so that's my my reflected sine graph. Now let's change our period. Oh, that has a -3 in it. Oh boy, this is going to reflect again. Let's change that. I'm not going to reflect it twice because if you reflect it again, it's not going to change it. Let's just make that a 3x. Okay, so when that's a 3x, then I'm going to take my original period 2 pi and divide it by 3. So this is now pi thirds, 2 pi thirds, negative pi thirds, and negative 2 pi thirds. So I've taken care of the period and the reflection over the x-axis. Now finally, let's move this to the right. So this is going to go right 2 pi over 3. Oh man. So if I go right 2 pi over 3, that's sort of silly because the entire that's what the period is. This is the period. Anytime you want to go right a multiple of your period, you're just going to put your graph right on top of the exact same graph. And so this will end up not changing. Will not change the graph. Does not change the graph. Because this equals the period. Okay, and so now I'm actually done. I can put in my, well, not quite done. I'm going to put in my vertical asymptotes and then my points at 1 and my rear parabola things. All right, so those are sine and, or secant and cosecant. They're sine and cosine all over again, and then with some asymptotes and reflections happening. So let's talk about tangent and cotangent. So y equals tangent of x has a period of only pi. So here I'm going to put in my pi, and I'll only go to pi this time since the period is pi. Pi and negative pi, and then my half marks. For tangent, remember, is sine over cosine. So because we have a cosine in the denominator, anytime cosine was 0, you have vertical asymptotes again, just like with secant. So cosine was 0 at the odd multiples of pi halves. So I'm going to have asymptotes at the odd multiples of pi halves. And then because sine is 0 at the multiples of pi, that's where tangent has zeros. And then the final thing to do here is to draw in your tangent curve. And this, again, is something that you learned in your trig class. You learned why this tangent curve looks the way it does, but this is how tangent looks. There's one important point. Halfway between 0 and pi halves at 45 degrees, or pi fourths, remember you hit the point 1. Okay. Cosecant is, or cotangent is very similar because cotangent is cosine over sine. We have cosine over sine. So now when I put in pi and negative pi and the half marks, now remember too, these have periods of only pi, so I'm just going to do 2 full periods where I start at negative pi and end at pi. So sine of x is 0 on the pi's. Whenever sine of x is 0, the cotangent is dividing by 0, and so we have undefined values there, or vertical asymptotes in the graph. And then whenever cosine is 0, which is at the odd multiples of pi halves, then I have that cotangent equals 0. So when the top equals 0, you have intercepts, points, and when the denominator equals 0, you have asymptotes. And then the cotangent graph has the same basic shape. except that instead of increasing, it will decrease. And again, you have a significant point here at pi fourths or halfway through to the 0. You have the point, you have the y value 1. And that just gives you a little bit of a scale. And so what are the similarities and the differences? Well, we definitely see similar branches. They're just reflected. And then the asymptotes and the intercepts are in different spots. So let's write those down. Similar branches, their reflections, and asymptotes of tan are zeros of cotangent and vice versa. They switch. All right, last two examples here. We're going to modify, we're going to shift around tangent and cotangent. So I'm going to go ahead and do that second one, and then I'm going to leave the first one for you to do. All right, I'm going to start like I always start, put in my period, my pi, my negative pi, and then the half marks. This is tangent. So tangent equals 0 whenever cosine equals 0, which is at the odd multiples of pi halves. So I have vertical asymptotes there, zeros on the pi's where sine is 0, and then I would go up. Okay, so this is the original tangent graph. I am just graphing tangent of x right now. I'm going to modify it next. Okay, so my amplitude, but this is not really an amplitude, but it's only a half. There's a half in front of that tan. That means that at pi fourths here, I'm really only at a half. And I'm just going to label that as such. And then the other thing that changes is that my period does change. And you have to be very careful when you talk about the period of tangent because it's a new formula. The period is now pi divided by pi fourths because we take the old period and we modify it by this factor. So no longer 2 pi, but pi. Take note of that. That's pi divided by pi fourths. So that's 4. Okay, so how does that change this x-axis? Well, this pi changes to a 4. This asymptote will be at 2. -2 and -4. Then, and so that's how my period changes. And then the last thing to do is to note that I'm going to go left. Let me change this one. Let me change it to a 2 so that we go left a nice amount. So I'm going to go left 2, no, yeah, 2 pi. I'm going to go left 2 pi over 4, which is 8. That's too far to go left. Okay, hold on. Okay, I'm working in green here. I changed the problem, so instead of a +1, it's a plus a pi fourths. Now, when that's plus pi fourths, we're still going to move left. We're going to move left pi fourths divided by pi fourths because pi fourths was the b value also. So we're going to go left 1. That means all of my asymptotes will move left 1. And did I do that right? I think that I put this one green asymptote where I shouldn't have. Let's do that again. Oh boy, taking them out slowly. Okay, so this one which is at 2 is now going to be at 1. The one that was at 4 is now going to be at 3. It wasn't at 4. It was at 4.5 or at 5, and so now it's going to be at 4. That's too many again. I shouldn't move that asymptote. I don't really have it marked at a spot. Okay, so this one at 2 is going to move left to 1. The one at -2 is going to move left to -3. This 0, who was at 0, is going to move left to 1. And then let me just draw him. Okay? And then we're going to have another one over here. This would go here. This 0, which was at 4, will now be at 3. And so the green graph is the answer there. And I have 2 showing. All right, I am going to let you do this one. It's just a period change, and then it's stretched out a little bit. This point is no longer at 1. It's going to be at 3. All right, and I will see you next time.